As a current doctoral student examining novel 3D printing and computational methods, my research focuses on structurally informed, functionally graded spatial 3D printing methods for large-scale construction. And this video showcases a workflow that I have currently been working on that takes structurally informed data from ANSYS, a FEM software, into Rhino, a 3D modeling software, where I can use that structural data to create a varied density spatial 3D printed toolpath. As you can see in the video, there are various colors being generated. Each voxel is representative of a different varied density continuous toolpath cell. The research goal is to use structural data to inform the 3D print toolpath, and to only use material where it's needed, reducing the material usage. In the video, you can see the result of the functionally graded cell generation. The next step in this workflow is to create a graph of the nodes and edges, so that each edge can be sorted for continuous printing. To accomplish that, I've created a plugin for Rhino that takes the input curves from the generated functionally graded geometry and outputs a set of 3D printing toolpaths that are color coordinated by their length. And here you can see the pink is the longest toolpath that I have. And then for this functionally graded spatial printing, I have the orange path, which is the longest possible curve for that option.